So this is one of my newest projects, and it combines my passion for UAVs with something new I'm learning, computer vision. So what you see here is a copter I put together myself using parts from here and there. There are a few key electronics on board though, radio flight controller running APM 2.6, a Spectrum RC receiver from Hobby King, a little Arduino Nano microcontroller that acts as the brain for the copter when I switch it to autonomous mode, and a radio TX-RX which I use to facilitate communication between my laptop running the computer vision algorithm, and the Arduino on board. So in order to track this copter, you'll notice two large pink dots on the underside of the copter. These make it really easy for me to spot and figure out the orientation of the copter when it's flying above my ground-based camera. I also built in a little deployment mechanism, so you can pop in small payloads to drop on precise targets. I'll show you this soon. The copter is able to actually utilize computer vision to do two things at the moment: drop a payload at a certain spot, and reorient itself along the yaw axis to eventually make precision autonomous landings, and eventually recharge on its own too. So what you see right now is the basic tracking happening. You'll notice two white circles which draw themselves around the dots I'm tracking when the computer vision system detects them in the proper configuration. There's still lots of improvements that need to be made, of course. So in payload drop mode, the copter tries to position itself over a certain area of the field of view of the camera, and once it's locked in there, it goes ahead with the drop. I need to work on improving the frame rate of the live video, or stability anyway, because the copter isn't really able to maintain its position perfectly, and the payload drops a few centimeters off target, as you see. In yaw adjust mode, the copter starts offset, as you can see here from the target yaw position, but it tries to readjust itself, in this case by rotating 90 degrees counterclockwise, and hold that position. A simple PID loop tries to make this process smooth, but as you can see, the algorithm loses many frames, so improvements definitely need to be made here. My goal with this project is to see how feasible it is, really, to use drones for deliveries. I think a fundamental challenge facing them from a technological standpoint is their inability to stay aloft for long periods of times, hence lessening their range and ultimately widespread implementation. If a network of charging and payload exchange stations could be created, creating almost a physical manifestation of the internet itself, I think the possibilities really become endless at that point. Anyway, thanks for watching, and as usual, your feedback and advice means more to me than anything else, so have a great day, and keep building your dreams. Thanks.